Hi, welcome back to a new math video, and today we'll be covering on prime factorization. So before we jump into prime factorization, we first know what a prime number is. So a prime number is a number that can only be formed by multiplying 1 and the number itself. So examples are 2, 5, 59, and 97. So continue watching to learn how to find prime numbers. So we need to take note that the number 1 is not a prime number. Any number that is not a prime number is known as a composite number. So examples are 4, 10, 25, 63, 98. This is because they have more than one factor. So for example, 4 here can be formed by taking 2 times 2 and 1 times 4. So now let's hunt for prime numbers. So the very first number that we can remove is actually the number 1, because we know that 1 can never be a prime number. So let's get rid of 1. Okay, so now we're going to remove all even numbers except for the number 2, because only the number 2 can be formed by taking 1 in itself, while everything else can be formed by more than one way, which is 1 in itself and divisible by 2 also. So we're going to remove all even numbers. So we're going to remove all the numbers here that has 2 in it. We're going to remove all the numbers that have 4 in it, all the numbers that has 6, all the numbers that has 8, and all the numbers that have a 0 at the end, because all these numbers here are all prime numbers. So we are done with the number 2. Now move on to the next number, which is 3. So now we're going to find all the numbers that are divisible by 3. But before we move on to 3, we're going to now remove all multiples of 5, because that's much easier. So all multiples of 5 except for 5 itself would be 15, 25, 35, 45, 55, 65, 75, 85, and 95. So all these numbers are all divisible by 5. Okay, so now let's move back to 3. So how do we find numbers that are multiples of 3? One trick to do it is to add the digits in the number and see if the sum of the digit is divisible by 3. If it is, then we know that the number that we're looking at is also divisible by 3. So let me show you an example. Let's use the number 21 as an example. So 21 has the digits 2 and 1. So 2 plus 1 equals to 3. So since the number 3 is divisible by 3, 21 is also divisible by 3. So let's look at, for example, the number 29. So 21 is 2 plus 9, which makes 11. So 11 is not divisible by 3, so 29 is not divisible by 3. So now we know how to find numbers that are divisible by 3. We're going to start hunting for the multiples of 3. Okay, so we know that we can not look at 3, so we move on to 5. Is 5 divisible by 3? No, it's not. 7 is not. 9. 9 is divisible by 3, so we can get rid of 9. Okay, so we can skip 11, because we know 11 is not. 13. 1 plus 3 is 4. So 4 is not divisible by 3, so 13 is not. Now, 17. 17 is 1 plus 7 makes 8. 8 is not divisible by 3, so we can move on to 19. 19. 1 plus 9 is 10. 10 is not divisible by 3, so we move on to 21. 21. 2 plus 1 is 3. So 21 is divisible by 3, so we can cross it out. 23. 23 is 2 plus 3 is 5. So 23 is not divisible by 3. 27. 2 plus 7 is 9. 9 is divisible by 3. So 27 is divisible by 3. 29 is not, because we just explained it earlier. 31. 3 plus 1 is 4. 4 is not divisible by 3. So 31 is not divisible by 3. 33. 3 plus 3 is 6. 6 is divisible by 3. So 33 is divisible by 3 as well. So we can cross it out. Now, 37. 7 plus 3 is 10. So 37 is not divisible by 3. 39. 3 plus 9 is 12. 12 is divisible by 3. So 39 can be crossed out as well. Now we move on to 41. 4 plus 1 is 5. So it's not divisible by 3. 43. 4 plus 3 is 7. 7 is not divisible by 3. 43 is also not divisible by 3. 47. 4 plus 7 is 13. 13 is not divisible by 3, so 47 is not divisible by 3 as well. 49. 4 plus 9 is 13, so 49 is not divisible by 3. 51. 5 plus 1 is 6, so 51 is divisible by 3. 53. 5 plus 3 is 8, so it's not divisible by 3. 57. 5 plus 7 is 12. 12 is divisible by 3, so 57 is divisible by 3 as well. 59. 5 plus 9 is 14, so 14 is not divisible by 3, so 59 is not divisible by 3 as well. 61. 6 plus 1 is 7, so it's not divisible by 3. 63. 6 plus 3 is 9, so it is divisible by 3, so we can cross it out as well. 67. 6 plus 7 is 13, so it's not divisible by 3. 69. 6 plus 9 is 15. 15 is divisible by 3, so we can cross 69 out. Now move on to 71. 7 plus 1 is 8, so it's not divisible by 3. 73. 7 plus 3 is 10, so it's not divisible by 3. 77. 7 plus 7 is 14, so it's not divisible by 3. 79. 7 plus 9 is 16, so 16 is not divisible by 3, so it's not. 81. 8 plus 1 is 9, so it's divisible by 3, so we can cross it out as well. 83. 8 plus 3 is 11, so it's not divisible by 3. 87. 8 plus 7 is 15, so it's divisible by 3, we can cross it out. 89. 8 plus 9 is 17, so it's not divisible by 3. 91. 9 plus 1 is 10, so it's not divisible by 3. 93. 9 plus 3 is 12, it's divisible by 3, we can remove it. 97. 9 plus 7 is 16, so it's not divisible by 3. And the last number, 99. 9 plus 9 is 18, divisible by 3, so cross it out as well. Okay, so now we have looked at multiples of 2, multiples of 3, multiples of 5. Now let's look at multiples of 7. So 7, like I said earlier, 7 can only divide by itself and get 1. So same as 2, 3, and 5, it is a prime number. 11, not divisible by 7. 13, not divisible by 7. Let's move on to 17. 17 is not. 19 is not as well. 23 is also not. 29 is not. 31 is not. 37 is not. 41 is not. 43 is not. 47 is not. 49 is divisible by 7, so we remove 49. So 49, then move on to 53. 53 is not divisible by 7. 59 is not divisible by 7. 61 is not divisible by 7. 67 is not divisible by 7. 71 is not divisible by 7. 77 is divisible by 7, because 77 divided by 7 is 11. 79 is not. 83 is not. 89 is not. 91 is divisible by 7, so we're going to remove 91. And 97 is not divisible by 7, so we have found all the multiples for 7. So the remaining numbers that we see here that are not cancelled out are all prime numbers. So all these numbers that are circled in orange now are prime numbers from 1 to 100. So we still can find prime numbers that are larger than 100, but we're not going to do it here. Okay, so now we can move on to the prime factorization part. So prime factorization is to actually reduce a number to its prime factors. So this means that we're trying to find out how the numbers can be formed just by using the prime numbers. So numbers that we have circled in orange in the previous slide. So we're going to use 20 as our example. So how do we find the prime factors of 20? So we first write the number that we want to find down, and then we write the giant L beside it. So we're going to divide it by the prime numbers now. So we're going to start with the smallest number, and that is 2. Can 20 be divided by 2? Yes, because 20 is a prime number, it can be divided by 2. So 20 by 2 is 10. So we're going to write 10 here. Now, is 10 divisible by 2? 10 is an even number, so it's also divisible by 2. So we're going to write 2. And 10 divided by 2 is 5. So is 5 divisible by 2? 5 is not divisible by 2, so we move on to the next prime number, which is 3. Is 5 divisible by 3? No, it's not. So we're going to move on to the next prime number, which is 5. Is 5 divisible by 5? Yes, 5 is divisible by 5. So 5 divided by 5 is 1. So once you reach 1, you know that is the end. So this means that 20 is equals to 2 times 2 times 5. We can rewrite it as equals to 2 to the power of 2. Why to the power of 2? Because there are two 2's. There is one 2 here and another 2 here, so it's squared. And then times 5. 5 here is actually to the power of 1, but we can just write it as just 5. So there's no need to write this to the power of 1 here. We can just leave it as 2 to the power of 2 times 5. So that's our final answer for the prime factors of 20. So now let's move on to the examples. So you can pause the video here to try it out and see whether you're able to solve the prime factors for 60 and 2160. Do it slowly, it's not very difficult. Okay, so now let's try to find the prime factor of 60. So first we're going to write 60 and then we're going to write the big L. So is 60 divisible by 2? Yes, it is. So you're going to write 2. And 60 divided by 2 is 30. Is 30 divisible by 2? Yes, 30 is divisible by 2 because it's an even number. So we're going to write 2. And then 30 divided by 2 is 15. Now, is 15 divisible by 2? 15 is not because it's not even number. So we're going to look, is 15 divisible by 3? 15 is divisible by 3. So we're going to write 3. And what we're left with is 5. Now, is 5 divisible by 3? 5 is not divisible by 3. So we're going to look at the next prime number, which is 5. 5 is divisible by 5. So we write 5. And what we're left is 1. So once we reach 1, we know we have completed it. So 60 is equals to 2 to the power of 1, 2. So 2 square times how many 3's? 1, 3 and 1, 5. So that is the prime factorization of 60. Now let's look at the prime factorization of 2160. So is 2160 divisible by 2? Yes, it is because it's an even number. So 2162 divided by 2 is 1080. Is 1080 divisible by 2? Yes, it is because it's also an even number. So what we have is 540. Now, is 540 divisible by 2? Yes, because it's also an even number because it ends with a number 0. And what we have is 270. 270 is also divisible by 2 because it ends with the number 0. And what we have is 135. Now, 135 is not divisible by 2 because it's not an even number. So we move on to 3. Now we're going to test it out. Is 135 divisible by 3? So we're going to add the digits. 1 plus 3 plus 5 equals to 9. 9 is divisible by 3. So 135 is also divisible by 3. So 3. And the next number we have is 45. Now, 45 is divisible by 3. We're going to try it out. 4 plus 5 equals to 9. Yes, so it is divisible by 3. So we're going to write 3. And what we have is 15. Is 15 divisible by 3? Yes, it is. And what we have is 5. Now, is 5 divisible by 3? 5 is not. Is 5 divisible by 5? Yes, it is. So 5. And we have reached 1, so we are done. So therefore, 2160 is equals to 2 to the power of 1, 2, 3, 4 to the power of 4 times 3 to the power of 1, 2, 3. 3 times 5. 5 to the power of what? Just 1. So just leave it as 5. So 2160 is equals to 2 to the power of 4 times 3 cubed times 5. So that is how you find the prime factorization of 60 and 2160. So that's all for us for today. So in the next 2 math videos, we'll see how we can use the prime factorization to solve some questions such as highest common factor, lowest common multiple. So remember to subscribe to the channel if you want to watch those videos, and always remember to stay curious.